Jazz.
Alright.
Now they know what class to do. Wait, are we not gonna grade our homework from yesterday?
Nope.
No, we haven't finished it.
We're gonna finish all of it.
We're gonna finish all of it. We're gonna go 1 to 10.
Alright. So this is stoichiometry of gases. Okay. In stoichiometry, you must have a balanced equation. Yes? Okay. And 2, you switch from your known to your unknown compound by using the volume ratio. Okay, before in stoichiometry we used the mole ratio where we read the coefficients off of the balanced equation. So what do you think you do for a volume ratio? Read the coefficients from the balanced equation. Okay. We have a relationship of 1 mole of any gas is equal to 22.4 liters in volume. And we can flip that to where it is 22.4 liters of volume is equal to 1 mole of any gas. Okay? So our volume ratio is done in liters to liters when you switch. Okay? Because this is your equality. 1 mole of any gas has a volume of 22.4 liters. So we use the volume ratio to switch from one compound to the other compound. All right. So we are going to do one-steppers first. That is a liter to liter type problem. Okay? We must have a balanced equation, so we've got C3H8 plus O2 produces CO2 plus water. Okay. So how many C's do I need over here? How many H's do I need over here? 8, but I've got 2, so what times 2 gives me? 4. Now, do your O's. 3 times 2 is 6, and 4 times 1 is 4, is 10 O's. So what do I put here? Okay. All right, so there's our balanced equation. My given is 0.350 liters of C3H8. My unknown is liters of O2. Okay? Alright, like any dimensional analysis problem, you always start with your given. 0.350 liters of C3H8. If I have liters of C3H8 here, what must go here? Mm-hmm. Who are we switching to?
Liters of O2.
So I put liters of O2. This is called your what ratio? Okay. All right. What do you read to find your numbers?
Coefficients.
Yes. So put in your coefficients. What's here? And what's in front of O2?
5.
Okay. So liters of that cancels, leaving you in liters of O2. Is that what you were supposed to end in?
Yes.
All right. Give me an answer, please.
1.75.
So 1.75 liters O2. Everybody good? All right, we're going to do one more quickly. So the given is 3.50 liters, same one. 0.350 liters of C3H8, unknown. Okay, is liters of CO2. So 0.350 liters C3H8. 1 liter of C3H8 to what? There you go. 3 liters of CO2. That cancels, leaving you in liters of CO2, and what is it? 1.05 liters CO2. Everybody good? Simple enough, yes? All right, let's go to two-steppers. This is two-steppers, okay, would be mole to liters, or what? Correct. Okay. All right. So we're going to use the same equation that you had on your one-steppers. Our given, though, is going to be 10.0 liters of O2. Our unknown is mole CO2. Okay? Now, when you did your dimensional analysis yesterday, you incorporated your mole and liter conversion factor over there, your molar volume. Yes?
Yes.
All right. So I start with what? Mm-hmm. Now then, I'm already in liters. Ding, ding, ding. You have to use your what ratio to switch?
22.4.
No.
The volume to mole ratio.
Volume to volume. Volume to volume ratios. Because I don't care about O2. My goal is first to get to who? CO2. So my liters of O2 to liters of CO2, yes? Okay. What's my coefficients? What's in front of O2?
5.
What's in front of CO2?
3.
Mm-hmm. All right, I'm no longer in liters of O2. Everybody agree? Now, I have liters of CO2 here, so I have to put liters of CO2 here. And on my board, I have a relationship between liters and moles, don't I? So 22.4 liters in what? 1 mole of CO2. Liters cancels, and you are now in the unit of mole. Okay? Do your math and give me your answer.
0.27.
Say again, honey, I didn't hear.
0.27.
0.27? 0.27 mole CO2. Okay? Everybody good? Questions?
Easy money.
Easy money. All right, let's flip it. Okay? I'm going to use a new equation. We're going to use the equation for water. A synthesis reaction to make water. What are the two elements in water?
Hydrogen and oxygen.
So, it's hydrogen diatomic. So, H2 plus what? O2 produces what?
H2O.
Okay, balance it. This equation will be used for all the rest of your examples. The water equation. What do I need in front of my H? And my water. Okay, we're ready to go. All right. You're given is 2.45 mole H2O. The unknown is liters of H2. Okay? All right, see if you can put that together. It's a two-stepper. It's basically what's flipped of the one above. .45 mole of H2O. 1 mole of H2O is how many liters, kids?
2.4.
Okay. Now I have liters of H2O, and I get to go to liters of H2. What are my coefficients?
2 and 2.
Okay. Mole of water cancels, liters of water cancels. Last man standing is liters of hydrogen. What's your answer?
54.08.
54.88.
54 point what?
88.
88. Yes? All right, so now we're going to a three-stepper. Okay. A three-stepper will take you from liters to grams or what? There you go. Okay, so we'll be tacking molar mass on in there. All right, so my given is 2.40 liters of O2. Your unknown is grams H2O. Okay? Still using your water equation, your balanced water equation above. Alright, so I start off 2.40 liters of O2. Now then, you have to be in what unit to switch, kids? Nope. Look up at your instructions at the top. No, to switch from O2 to H2O, what unit do you have to be in? Liters. So it's time to switch. Are we in liters? So it's time to switch. So liters O2 to liters of H2O. Everybody with me? Because I have to get to H2O. I don't care about anything about O2, and as soon as I can get rid of O2, I get rid of O2. Does that make sense? All right, so my coefficients in front of O2 is a what? And my coefficient in front of water is a? Okay. Now I'm in water. Okay, from here, I got to have liters of water on the bottom, yes? And that is my 22.4. And it's always per 1 mole of whatever gas. Okay, so now I'm in mole, which then takes me from mole to what? Grams. 1 mole H2O is X number of grams of H2O. And add up water on your periodic table. Or is it 18.015 if you use our period? 1015.015?
I didn't do that in my head, so you can do that.
All right. So everything has canceled on the diagonal. Do your math and get me an answer, please. Thank you. There you go. Okay. Now, our last one that we're going to work is going to be what?
Grams and liters.
Yes. So grams to liters. This also is a three-stepper. Okay, I'm going to give you the given. Let's see if you can get to the unknown on your own. So, given, still using the water reaction above, 25.0 grams of H2O. Unknown is liters of H2. Okay? What goes down here?
7.015.
We're H2O.
What goes on top?
2 mole H2O, right?
1 mole
That's what I said.
H2O. You never use the coefficients until you use the volume ratio. Okay? Now, what goes down here?
1 mole H2O.
Mm-hmm. It's what?
22.4 liters H2O.
Mm-hmm. And then what?
2 liters H2O.
Yes. And what?
2 liters H2O.
There you go. And you got what? A little more than 25 grams. About 28.
I got 31.
Is it that much more? How much?
31.09.
Okay. So 30.09?
No, 31.
31, my bad. Could you see you got your dividing by 18 and multiplying by 22, so it's going to be, they don't quite offset each other, but close, pretty close. All right. And that is liters of H2, and we are done.